Good day, students. This is Chapter 6, Lesson 2, looking at changes in state. Some of the key concepts that we're going to look at are how is temperature related to particle motion, how are temperature and thermal energy different, and what happens to thermal energy when matter changes from one state to another. So just to review some different things, kinetic energy is the idea of energy an object has due to its motion, so it's energy of motion. The faster particles move, the greater the kinetic energy an object will have. Solids have the least amount of kinetic energy than liquids and gases because you're looking at how much energy they seem to have. Temperature is the measure, this comes from the last chapter, is the measure of average kinetic energy of all the particles in an object. So what we'll see is that some particles move faster than others, some are slower, so we take the average of all of them to get the temperature. So how is temperature related to particle motion? The greater the temperature, the greater the particle motion we'll see. So if we increase the temperature, we're going to increase the particle speed also. We want to look and review potential energy. We need to talk about the fact that potential energy is the energy of particles due to their position relative to each other. The farther apart particles are from each other, the greater the potential energy. Here's looking at a diagram looking at greater versus less potential energy. We're seeing that the particles, that we have a greater distance between the ball and the floor, so we have greater potential energy there compared to right in this spot. We also can see that there are, oops, let me see if I can, their image is cut off. Let me see if I can make this a little bigger. There you go, now you can see the whole image. And what we're looking at is the greater the distance between particles, the greater the potential energy is. So the gases are going to have greater potential energy compared to a solid. Whereas, so we're looking at the gas particles inside the ball, they're much farther out, they have a lot greater energy compared to the particles in the solid floor. And we're going to see that the greater the distance between objects, the greater the potential energy also is. To remind you that thermal energy is the total potential and kinetic energies of the object, so you have to put those two combined. Adding or removing thermal energy is going to cause a state change, so that's the big thing that we're going to look at that's going to cause the change of state. We'll get into the specifics here, but adding thermal energy is going to cause the particles to move faster, so you're increasing the kinetic energy. That's going to cause the particles to move farther apart, which increases the potential energy. And so then we also can see that it can cause them to move particles to get faster and move farther apart, so you can see it doing both. So you can see all three of those options depending on how thermal energy is being added. So solid to liquid or liquid to solid. So the change in matter from solid to liquid, thermal energy must be added. So melting is the change from a solid state to the liquid state. The solid gains thermal energy. The temperature at which a solid changes to a liquid is known as the melting point. So once it has reached the melting point, additional thermal energy is going to be used to overcome the attractive forces of the particles, causing the particles to move farther apart, causing the change from a solid to a liquid. So what we can see here, if we look at energy changes, at first thermal energy and temperature will increase. So we're going to see that both the temperature and the potential energy, both the potential and kinetic energy are going to increase in this situation when it's a solid. Once it reaches the melting point, so this structure here you see it flatlines, and what we're going to see here is that the average kinetic energy has to stay constant, but the potential energy is going to increase. So we're going to see that the thermal energy increases. The reason behind that is we're going to see that the temperature stays constant because it's using that other thermal energy to overcome the attractive forces necessary to go from a solid to a liquid. Once we see that it overcomes those attractive forces, we're going to see a change from, in this case it's showing going from solid to a liquid, and then again we'll see both the temperature and the potential energy will increase. So at each point when it is going through a melting or a change of state, we're going to see that the graph will flatline out. So let's look at the opposite. So freezing is the change from a liquid state to a solid state. This is when we're going to see that the liquid loses thermal energy, or it's being transferred out of it. The temperature at which a substance changes from the liquid state to the solid state is called the freezing point. This is going to be the opposite of the melting process. We can look at the opposite, the idea of going from a liquid to gas or gas to liquid next. And the idea of vaporization is the change from a liquid to a gas. So the liquid is going to absorb thermal energy, so it's going to gain thermal energy. We have two different types of vaporization. We have boiling and evaporation. Boiling occurs below the surface. So the temperature at which substances change from a liquid state to a gas state is called the boiling point, and energy changes occur in the same process as melting occur. So again, we're going to see an increase in temperature and energy until we get to that point of the boiling point, and then temperature will level off, and we'll see just the potential energy increase. Evaporation is at the surface, so it's the same process, but it's going to occur at the surface. So here we can see again, as a liquid, temperature increases, potential energy, there's not a whole lot going on. Then when we get to the vaporization point or boiling point, we're going to see that it levels off. The temperature will stay constant, but the potential energy is going to increase. And then once it has been converted, at this point it'll convert from liquid to a gas, and then we're going to see the temperature increases and potential energy will have little change. The opposite reaction is looking at condensation, and that is the idea of going from a gas to a liquid. It's going to release thermal energy. This causes the particles to slow down and collect. Good examples of this would be like clouds and rain and so on. We're going to see to get this condensation. We can also look at a couple processes where we skip the liquid stage and we go straight from a solid to a gas or gas to a solid. Sublimation is the process when a solid goes to the gas form without becoming a liquid. So it's going to need to absorb thermal energy. A good example of this is dry ice. It goes straight from a solid straight to a gas. Deposition is the opposite, and that's where it's going to go from a gas to a solid without becoming a liquid first. So it's the opposite of sublimation. And a good example of this would be frost in the grass in the morning. So it's going to go from a water vapor in the air to a solid form of ice on the grass. It never is at liquid state. We can look at the states of water, and the idea that water is the only substance that exists naturally as a solid, liquid, and gas on Earth. At 0 degrees Celsius, water molecules vibrate so rapidly that they begin to move out of their places, the particles overcome their attractive forces, and melting occurs. So 0 degrees is the melting point for water. We can also look at 100 degrees, that's the boiling point of water, and that's going to go from a liquid to a water vapor. And then cooling water vapor, when it goes the opposite direction, will go from water vapor to liquid is condensation, and then when we go from liquid water to solid, that would be ice. So we can see here, make this picture just a little smaller for you. See here, looking at the heating cup of water, we can see that here it's a solid. When it reaches the melting point, this flatlines out, and then when it's now in a liquid, it's going to see temperature increasing, and then when it gets to the boiling point, it levels out, and then when it becomes a gas, we're going to see the temperature increase. So we see this kind of step-like motion that occurs. Here's just another kind of summary. We're always going to see that it doesn't matter what state change occurs, we're always going to see that the matter energy is conserved. So it has to go somewhere. So the same amount of solid water, you're going to have the same amount of liquid, same amount of gas. And here is just giving you a nice example of if we go from a solid to a gas, it's called sublimation. We have to add thermal energy. If we go remove thermal energy, it's called deposition. If we take solid ice and go to liquid, it's called melting, and we have to add thermal energy. So this diagram does a really nice job of summarizing the different state changes. If you have questions, bring your class. Otherwise, we will continue from there into lesson 3. Thank you.